Yeah, so hello everyone, welcome to OneClass Services channel. My name is Devansh and today we'll see some popular physics question. Now these questions are going to be at, let's say, high school level, and it can be at university level, but mostly it is going to be at high school level. And so a little background of myself. So I am in the final year of my graduation in aerospace engineering. And yeah, if you need any one-to-one live sessions or if you need any tutoring help, they can check the links in the description below. And so without wasting your time, I'll just start with the stream. Yeah. mm, so that this is from my last stream, so I'll just add a page here. Yeah. Okay. So we'll start with question number one. So this is, I'll just start with red pen. So it is saying that two plane mirrors are separated by 120 degrees as the drawing illustrates. So we cannot see the drawing obviously. Now if a ray strikes a mirror M1 at an angle of 56 degrees, that means angle of incidence is 56 degrees here. Uh, at what angle of incident that does it leave the mirror? They don't have spaces here. Like it is very hard to read without spaces. So I'll try to make this, and let's say this is the other mirror. Let's say this is M1 mirror, this is M2, and let's say this is a mirror, so it will reflect everything. And now the angle here is 120, and let's say the ray is striking at this point, the ray, first ray. So, and it is making an angle of 56 degrees. So what we do is that we first make a normal here. I'll just make this normal with blue color. So this angle is going to be 90 degree, and the ray, I'll just make the ray with the black color. So the ray is coming from here, and it is making, yeah, finally straight line. So it is making 56 degrees here, and like there is a property of reflection. So basically in the case of mirrors, angle of incidence is always equal to angle of reflection. So when this ray is reflected back, let's say like this, so it will make an angle of 56 degrees. So let's say this point as A, and let's say this is B, and um, um, let's say this as normal N1. um, I'll write this with red. So this is normal N1. So my my angle BAN1 is going to be, let's say just for now, let's say this point is C, will be equal to angle N1 AC, and this will be 56 degree, because the law of reflection, you can say. Now, so we have got this angle. Now what we'll do is that we'll just try and we'll extend this such that it meets the mirror M2, and it should be a straight line. So I'm just drawing a dotted line here. Mm, Um, yeah. So again, and when this ray is striking this mirror, so I will draw a normal which will be perpendicular to this. I'll just use the angles. Now we are going to just play with this. So here we can clearly see that this is the normal to this surface. So n1 is the normal to m1 surface. So this whole angle is going to be 90 degree, and this angle is 56. So this angle will be 90 minus 56. So it will be 90 minus 56. It will be 34 degree. And we can clearly see that this is a triangle, and sum of the interior angles of triangle is 180. Sum of interior angles of triangle is 180 degree. So we can find this angle. So this will be 120 plus 34 whole subtracted from 180, and this will be 120 plus 34, 180 minus this will be 26. So this angle is going to be 26 degrees, and again this whole complete angle is 90 degrees, so I can find this one. So this one will be 90 minus 26. 90 minus 26, this is going to be 64 degrees. And again, angle of like law of reflection, so angle of incidence will be equal to angle of reflection. So let's say this is 64 like this. In the question, okay, so first thing is that we need to calculate it I2. So I2 is going to be 64 4 degree, and it is asking that does it leave the mirror M2. So yeah, it is leaving the mirror M2. Let's just cross check with the solution here. So yeah, 64 degree, and by fact one that theta equal to 64 degree. Okay, so the solution given here was correct. So I'll just say correct solution. Good work. Okay, so a problem from mechanics. So it is saying that block X and Y of masses mx equal to 5.12 kgs and my equal to 3.22 kg are connected by a fishing line passing over an essentially frictionless pulley. Show that block X slides up the incline with a positive acceleration. Determine the magnitude of that acceleration. Friction is negligible. Determine the magnitude of uh, tension in the fishing line. So this is our question number 2, and I'll just try to draw this first. This is going to be 37 degree. Here we have a pulley. Here we have one box, and this pulley is attached here, and then let's just make this also. This string will go here. Wow. And one box is here, and this string will come here. And just so let's say that this is m1, mass here is m2, and it is clearly given that the acceleration is going to be positive x. So positive. I'll just write the acceleration is going to be on this side, and what else is given, that the surface is frictionless. Okay, we do not have to go for any friction. Now I'll draw a free body diagram for this block. So for this block, tension on the string is on this side. This and this will be, so this is mg, the weight of the block, and this will be mg cos theta, and this will be mg sin theta. And the acceleration is in this direction, so let's say it is a, and I can write, so summation of all the forces in this direction, this will be parallel to the surface, so it will be t minus mg sine, this is m1, so I'll just write 1 here, m1 g sine of theta equal to m1 into acceleration, or it is nothing but force, and the acceleration we know that it is a, so m1 into a will give us the force. So this is equation number 1. Now we'll draw a free body diagram for this one. So for m2, we have tension on the upper direction. This will be m2g, yeah, this will be m2g only, and my acceleration is in this direction, so I can write the force, that will be t, no, that will be m2g minus t equal to m2 into a. This is equation number 2. So I'll just solve this equation 1 and 2. I'll write this equation 1 here also. So this will be t minus m1 g sine theta. This is m1 into a. First I wanted to just tell you that I have assumed the acceleration is going in the upper direction, like as it is mentioned in the question. So if I get a positive value of acceleration, then my assumed direction is correct. If the acceleration comes out to be negative, then my um, assumed direction was not correct, and it is going to be the opposite direction. So I'll just add these two, and t will get cancelled. This will be m2g minus m1g sine theta. So this will be m2g minus m1g sine theta, and this will be m2 plus m1 times A. So A will be m2g minus m1g sine theta over m1 plus m2. Now we need to just put the values. So I'll calculate this. M2 is uh, M2 is given as 3.22 into 9.8, the acceleration due to gravity, minus this is M1 is 5.12 times 9.8 times sine of 35.7. So that theta is nothing but this sine of that, or sorry, theta is nothing but 35.7 degree, the inclination angle. And this will be divided with the sum of both the masses. So this is 3.22 plus 5.12. So the acceleration comes out to be 0.2729 meter per second square. So yeah, the acceleration first, the acceleration is positive. So our assumed direction was correct, and hence the direction is similar with the direction given in the question. So for the A part, show that block X move up the incline. Yeah, so it is moving up the incline because the acceleration direction or the value of acceleration is positive. And second, determine the magnitude of acceleration. So we have determined the magnitude of acceleration, which is 0.2729 meter per second square. Now we need to calculate the tension in the string. So to calculate the tension, I'll just put the value of this acceleration in second equation. So put A in equation 2. So T will be m2g minus m2a. m2g minus m2a, which is 9.8 minus 0.2729 into m2 is 3.22. This is 30.677 newtons. Newtons. So we have also done the B part. Now I'll just check. There is no solution given here. Oh God. So this, I'll just say that the solution is incorrect because no solution is given. Solution is given or it is not visible. We have to write the answer also. So here the block X moves up the incline with 0.2729 meter per second square as the acceleration, and tension in the string is 30.677 Newton. We'll go for question 3. So I'll just add one page here. So question number 3, I'll write with red pen now. So there are two particles A and B moving with a constant speed v1, which is less than v2 respectively. A start moving. So basically this should be A starts moving from the origin and keep moving on the positive x. So here we have the diagram. We can clearly see the direction. At the same time, B is moving from 0 to L. Aim to catch up A. The direction of vector velocity v2 always passes through A. So the v is kind of changing. Determine the time required to B for B, basically for B to catch A in term of v1, v2 and L. So first I'll draw this, and this is the direction of v2. v2 is starting from L, this is 0, and this one is v1. This is x direction. Now what I can see that if this is catching, let's say here, okay, then it is forming a right angle triangle. And for this right angle triangle, we can clearly see that the distance, so this distance or this length is L. This will be, let's say, A to B. So AB will be, we are going to use the formula speed is equals to distance over time. So speed is equal to distance over time, or distance is speed or velocity into time. In this case we have velocity, so it will be velocity into time. So AB is going to be v1 into t, and the so for this length and for this length we have this L length, we have this length, but the length of hypotenuse is not known. So again I can just say, let's say this is C. So CB is going to be v2 into t. Now I'm going to use Pythagoras theorem for this triangle. So it will be L square plus v1t whole square equal to v2t whole square. Now I'll just write L square plus v1 square t square equal to v2 square t square. Here the time is going to be t only because we are assuming that at this point it is catching v2 and both of them are going to take same time. Now I am going to um, solve this equation in terms of solving this equation for t. So t square will be, I'll just go stepwise. So it will be L square will be v2 square t square minus v1 square t square. I can take t square common here. So L square will be t square v2 square minus v1 square, and I can divide both the sides with v2 square minus v1 square. I'll get t square as L square over v2 square minus v1 square, and now I'm going to take the square root. So after taking square root, I'll get t equal to L square over v2 square minus v1 square, which will be nothing but L over under root of v2 square minus v1 square. So we had to find the time t in terms of v1, v2 and L. Let us cross check this with the solution given here. So let the ball A be moved for t second before ball 2 catches up. I hate this when these spaces are not there because it is very difficult to read. So Pythagoras theorem, yep, so they have done the same thing. So I can just say correct solution, good work. And the solution is correct. This was question 3. This is going to be question 4. Yep. So yep. So this was question 4. Yep. And we'll see the solution. So question number 4. What is the time constant for the discharge of the capacitor in the figure? We have two resistances in parallel, so sorry, in series, and again this is repeating the same question again and again. So for this I can write R equivalent will be R1 plus R2, that will be 1.0 kilo ohm plus 1.0 kilo ohms. So R equivalent will be 2 kilo ohms, and I can draw this circuit. So this will be, well, technically this should, it doesn't have an EMF, but yeah, capacitor will act as a battery also. And this was 10 microfarad, and I can write this whole as one resistor of 2 kilo ohms. Right. So let's just look at the solution. So yeah, 2 kilo ohms, and now the time constant. What is the time constant? Yeah, so time constant is nothing but resistance into capacitance, or R equivalent into capacitance. So it will be um, 2 into 10 power 3 into 10 into 10 power minus 6. This will become minus this will be 2 into 10 power minus 2. So this will become plus 4, and this will be, yep, so 2 into 10 power minus 2 farad. Sorry, not farad, it is time constant, so it will be second. So it will be second, or they have already converted into milliseconds, so it will be nothing but 2 millisecond divided by 100. 1 millisecond, 100 millisecond is 1 second, so um uh, 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 okay, yeah, 10 power 6, yeah. So the solution given here is correct, and I can just write correct solution. Good work. So basically these kind of questions are really easy. We just need to use the series formula, or we just need to simplify this in a simple LCR circuit, and then we can clearly find the answer also. Okay, so we have question number 5. This is question number 5. This is a very lengthy question, I think that. So the figure below shows a cold package of hot dogs sliding right rightward across a frictionless floor through a distance d equal to 20.5 centimeter. So I'll write d equal to 20.5 centimeter and d is 20.5 centimeter, while three forces are applied to it. So we can clearly see the forces here. The magnitude of force is two forces. Two of the forces are horizontal and have the magnitude. F1 is 5 Newton and F2 is 1 Newton. The third force is uh, angled down by theta equal to 65.0 degrees and has the magnitude of 4.00 Newton. For the 20.5 centimeter displacement, what is the net work done on the package by the three applied forces, the gravitational force on the package and the normal force on the package? Okay. And if the package has a mass of 2.4 kilograms, then and an initial kinetic energy of 0 joules, what is its speed and the end of the displacement? So I will first look at the solution given by junior tutor. Um, so work done, they have calculated. Okay, so they have first resolved these forces. So I'll just draw a vector diagram, free body diagram for this. So let's say this is the point mass, or the hot dog bag. This is F1 and this is F2. This is F3 and the angle is theta here. So I'll take the component. This will be F3 sine theta and this will be F3 cos theta. Um, so the from the figure we can clearly see that the direction of this hot dog bag is in the positive xward direction. So I'll just take the forces for x direction. I'll just sum it up. So it will be summation of forces in x direction will be F1 plus F3 cos theta minus F2. Let's just calculate this. So this will be 5 and then plus F3 is 4 into cos of 65 and F2 is 10 1.00. So I'll just calculate this. This is 4 times cos of 65 and then plus 5 minus 1. This will be 5.69 newtons. And we need to find the work done. So work done is going to be summation of Fx into the displacement. So this is 5.69 newtons and my displacement is 20.5 centimeters. So we'll just convert it. So this will become 0.205 meter times 0.205. So it is 1.1664 joules. So this is 1.1665 joules. I'll just cross check this with the solution here. Okay, so 1.166, they have 1.17. And work done by the package, we applied force of the gravitational force on the package and the normal force on the package. So the gravitational force on the package is, they haven't calculated the what is the net work done on the package by the three applied forces, the gravitational force on the package and the normal force on the package. Okay, so the thing is that the gravitational force is going to be in downward direction, which will be mg, and the normal force is going to be obviously in the upward direction. So the thing is that the displacement is in positive x direction, and the formula for work done is, it is like f into displacement into cos of theta. So the f direction is, like this, will be downwards, and the displacement direction will be in the positive x direction, and this will be 90 degrees. So because of this gravitational force, the work done will be 0 because cos 90 is 0. So we won't be taking any component, we won't be taking considering the normal or and the weight. But if it was a friction, like if it had any friction, then we would have definitely taken the normal. But here we won't be taking it. So the first part is done. And if the package has a mass of 2.4 kilograms and an initial kinetic energy of 0 joules, what is the speed at the end of the displacement? So work done is nothing but change in kinetic energy, and k1 is given as 0. I can just write ki minus kf minus ki. This is final kinetic energy minus initial kinetic energy. So ki is given as 0. So I'll just write work done we have already calculated, which is 1.1665. Kinetic energy will be half mv square. M is given, which is 2.4. So this will be 1.1665 equal to half of 2.4 v square. I'll just multiply this both the sides with the 2, divide both the sides with 2.4. So I'll get 1.165 into 2 over 2.4 equal to v square. I'll just take square root on both the sides. This will become into 2 divide 2.4 and then square root of answer 0.9859. So velocity will be 0.9859 meter per second. And let's check the solution also given here. So k2 minus k1, final minus initial, and then they have got 0.987. So we have got 0.9859 because we took the value, the work done as 1.1665, and they took the work done as 1.17. So this much of error is acceptable and the solution given here is correct. So I'll just say correct solution. Good work. Um, Yep. So now we have, this is question number 6. I'll just add a new page. We have question number 6. Um, so what minimum impulse must be imparted to a football of mass 0.425 kg to have a horizontal range of 43.0 meter? So I'll take the range formula from the solution only. I'll just write first the given values. So given is um, mass is 0.425, and then the range is 43 meter, and this is for the A part. So I'll just take the formula of range from the solution. So range is v square over g. So we can calculate v velocity. So v will be square root of r into g. So v will be square root of 43 into 9.8. This will be 43 into 9.8, square root of answer. This is 20.528 meter per second. Five, 2 and 8. Yeah. Now what we'll do is we'll write the formula of impulse. So the formula of impulse is nothing but um, the formula of impulse is nothing but mass into velocity. Sorry, force into velocity. So it will be okay. So it will be 20 times um, 0.425. So impulse is mass into velocity. Impulse will be, velocity is 20.528 and mass was 0.425. So this will be 8.7244. 7244 Newton second. The solution given 8.73. So yeah, that is acceptable. Now it is saying that assuming that contact with the football is maintained as it moves 17.0 centimeter, estimate the time of contact and the average force on the football. So I'll just start with the solution given here. So for this, what we say, first we find the work done, which is nothing but change in kinetic energy, and the initial kinetic energy is 0, and work done is force into displacement. So this is half mv square. Then force will become half of d, 1 by 2 times t into mv square. I'll just keep all the values. So this was what was d? D was given d, just a minute. Yep, so d is given 17.0 centimeter. So this will be 0.17, and this mass is 0.42, and um, V was, what was V? Yep, 20.528 and whole square. So it will be 0.42 times 20.528 square divided by 2 into 0.17, 520.55 newtons. 20.55 newtons. So we can clearly see that we have an error of 6 newtons. This was 20.53. Okay, so this 20.53 was responsible for this error. If I just divide it with, okay, so 20.53 was not the source of error. Actually, I rounded this, so I should have added 5 here also, and then it will give 526.74. 526.74 newtons. And again, impulse is force into time. So my impulse was 8.244 equal to force is 526.74 into time. So time will be 526.74 over 8.7244. Yeah, so basically why we are calculating this impulse, because with the impulse is nothing but force into time, and with this we can calculate or we can find um, the time period for which uh, the time of contact and the average force, the force we have calculated. This was the force 526.74 newtons, and the average time of contact we are calculating by this. So this will be divided by 8.7. I wrote it in opposite. Let me just cross check this. Yeah, so I actually wrote it in the opposite way. So this will be 8.7244 over 526.74. So 8.7244 divided by 526.74, 0.0165 second. Yeah, so the solution given here is same, and again I can say that the solution given is correct. So correct solution would work. So basically I'll just stop the session here only. Yeah, so I actually I have to go to somewhere, so I'll just stop my stream here only. And this was pretty much all for this session. And if you like this session, then please do hit the like and subscribe button also, and do hit the bell icon so that you will always be updated with our next live streams. And this was Devansh, senior tutor at OneClass. And if you need any homework help, I'm telling you, just check in the links below. Or if you need any like tutoring help or one-to-one live sessions, then go to those links. You will find a lot of help from there only. And so that was pretty much all, and I'll see you soon in my next stream. So till then, bye.